In this video, we're going to write some formulas for exponential growth. So they are of the form y equals c times a to the x. A familiar form would be a linear equation that's y equals mx plus b. This is just the exponential form of that. So you have c times a to the x, and c is your initial amount. In the y equals mx plus b, that linear example, b is the initial amount. For an exponential, c is your initial amount. And then normally in a linear function, you have a slope that you add each time you go up to over 1 or something like that. Here we have a growth factor. So instead of adding, we're multiplying for this exponential growth. And we want to remember that a is a growth factor, not a growth rate. A growth rate is going to be given as a percentage, and we're going to have to change it to a factor. So looking at some examples of just setting this up, we have the initial population is 5,600. So there's my C. And the population triples every time period. So C is definitely 5,600, whatever the initial amount is, and we want the population to triple. So we want to think about what that factor would be. Tripling means it is going to be times 3 each time period. So we're going to write this as y equals 5,600 times 3 to the x. C times a to the x. If we look again at the next one, we have the initial amount of money in an account is 45,000, and it has a growth factor of 1.05. So initial amount is 45,000. That's our C. And we're given the factor that we need, so that's our A. So we're going to write this as y equals C times a to the x. So 45,000 times 1.05 to the x. Now, this last one is a lot more difficult because we're given the initial population is 53 million. So be careful on this. C is just going to be 53. We're not going to write a bunch of zeros. They didn't give us zeros, so we're not going to put zeros on it. It's just going to be 53, which stands for 53 million, which means if you plug in an X value and you get out 65 or something like that, it doesn't stand for 65 people, it stands for 65 million people. So if you have zeros written for you, like the one above is 45,000, C is 45,000. But when the zeros aren't given and they want you to write it as a word, we're just going to write C is just a plain old 53. And now the other hard part about this is that the population increases by 3.4% every year. So we're given a percent. We're not given the growth factor, we're given the growth rate. So percent means it is a growth rate. But to plug into the formula, we need a growth factor. That's what A is. So we need to get this out of being a percent. So first thing we're going to do is we're going to divide this 3.4% by 100 to make it a decimal instead, which is going to give us 0.034. And we want it to grow. So if we multiply that 53, which stands for 53 million, by 0.034, it's going to get smaller and smaller when it's supposed to be getting bigger and bigger. So we need to add 1 to this. That way we can keep the 53 million we start with. By adding 1, we'll have 1 times 53. It's going to stay 53, but not only is it multiplied by 1, it's multiplied by 1.034. So it's going to stay 53 and get that 3.4% bigger. So we had to do a conversion. Last time it was nice we were given a growth factor. If we think about this, it's 1.05. 1 means it's growing, and then it's 0.05 bigger than 1. So this one had a growth rate of 5%. So they would have said the growth rate is 5%. We would divide by 100, see that that's 0.05, and then we add 1 to get the growth factor of 1.05. But they gave it to us nicely in that one before. Here we had to find it ourselves. We're going to practice this a lot in more videos to come. So we're going to have y equals 53, the initial amount, and we change that percent to being a factor. We're going to multiply by 1.034 raised to the x. There's our y equals c times a to the x.